Hello, Algebra 1. Welcome to Lesson 7.3 on multiplying special cases. This is our second section covering multiplying polynomials. But this time you're going to see it involves what we call the special cases. And you're going to see that all the special cases involve what are called perfect squares. So an example of a perfect square would be the number 25, right? Why is 25 a perfect square? Because 25 equals 5 squared, right? These are called perfect squares. So you'll see that the multiplication we do involves a couple different types of perfect square formats. Okay, so here's the first one. Determine the square of a binomial. Why is a plus b quantity squared considered a special case when multiplying polynomials? Well, first and foremost, all right, we have to understand that a plus b quantity squared does not equal a squared plus b squared. This is not distributive across addition. Exponents are not distributive across addition. Okay? To use the distributive property appropriately, we have to write a plus b twice. Because what does it mean if you square something? What does x squared really mean? It means x times x. Who cares what's being squared? Whatever is being squared, you multiply it by itself. Write it down twice. So a plus b squared is a plus b times a plus b. And now we use our multiplication of polynomials idea from last lesson to simplify this. So we do the a to the a and the a to the b. A times a is a squared. A times b is just positive a b. Nothing changes, just write them next to each other. And now we do the positive b to the a and the positive b to the b. Positive b times a is positive b a or a b. The order doesn't matter how you write them down in terms of multiplying two variables. And then positive b times positive b is positive b squared. And you'll see that the middle terms ab and ab are the same. They're both a positive 1, so they will combine to get plus 2 ab in the middle. And then the a squared flanks the beginning, and the plus b squared cabooses it at the end. And this is how your special case here, a plus b squared, multiplies out. Now visually, right, we did this the other day, so we create our tic-tac-toe board, two binomials, normal tic-tac-toe. This stays blank. We put an a and a b here because they're both positive, an a and a b here. A times a is a squared, a times b is a b, b times a or a times b is a b, sorry. And then b times b is b squared. And again, you see that the ab and the ab are the same. So this is a squared plus 2ab's plus b squared. Same idea, right? So you notice here that when you have we call this a perfect square or square of a binomial, a square of a binomial. Notice that the a gets squared, the b gets squared, and then the middle term, this 2ab, is the product of a and b, a times b, and then you double it because you get two middle terms that are exactly the same. This is what is called the square of a binomial. The square of a binomial follows this pattern right here. So it is not necessary that you remember this, but if you do, great. Okay. So there you go. Little shortcut. All right, so let's go ahead and try to use this. Okay, so what is the product of 5x minus 3 squared? So again, let's take a look at the formula, right? So the formula would say, okay, now it's a minus b squared. Well, it's going to end up being a squared. You're going to have a minus 2ab in the middle, and then you'll have a plus b squared at the end. Okay. So here we go. So we're going to square the first term, right? So that's going to be at 5x squared. We're going to square the last term. It's going to be a negative 3 squared. And then we're going to multiply 5x by negative 3 and put a 2 in front of it. Okay, so 5x squared is 5 squared and x squared. That's 25x squared. The negative 3 squared at the end is a plus 9. And then in the middle here, 15x times negative 3 is negative 15x. And we double that to get negative 30x. And there you go. Now again, you can just use our normal distribution rule, right? And you can do 5x minus 3 times 5x minus 3. You can do 5x to both the 5x and the minus 3. That gets you 25x squared. 5x times 5x is 25x squared. And 5x times negative 3 is negative 15x. Do the same thing down here. Negative 3 times 15 is negative 15x. Or negative 3 times 5x is negative 15x. And negative 3 times negative 3 is positive 9. And then your middle terms are going to combine. So you get 25x squared minus 30x plus 9. Which is exactly the same as up there. Again, doesn't matter. Okay, one more of these. So now we're going to continue at the theme of using it for numbers, right? So now how can we use the square of a binomial to find the product of 29 squared, right? So we can think of 29 as 30 minus 1. You could think of 29 as anything, right? You could think of it as, if you know what 25 is, you could think of 25 plus 4. You can think of 20 plus 9. But 30 minus 1 is the closest. So instead of writing it as 29 squared, let's think of it as 30 minus 1 squared. So again, how do we do this? Well, we square the first term, 30 squared. We square the last term, negative 1 squared. And then we multiply 30 times negative 1, and we double it. This is 900. The last number is a plus 1. And in the middle here, we get 30 times negative 1 is negative 30 times 2 is negative 60. If we combine these numbers, 90 minus 60 is 840. 840 plus 1 is 841. And that's a quick little party trick, right? If you want to impress your friends, there you go. How do you find 29 squared? 841. Right? So those magicians that do these kind of things, they have these rules memorized. All right, anywho, there you go. This is video 1. Video 2 is coming up next.